to finalize this particular section. So find the tangent plane and normal line. Bothers me. Anybody still working on this page? Okay, you are find the tangent plane and normal lines which to the surface x squared plus y squared plus z squared equals 30 at the point 1, -2, and 5. Okay, so we have two things to find: no tangent plane and normal line. And the surface obviously is a sphere. So we start with the tangent plane because I talked about it quite a bit. So let's see, we need to find the gradient first. So we're going to set up a function. We're going to ignore the 30. We're going to say, all right, we have a function f of x, y, z. So I can write it, let's write it specifically like so, equals x squared plus y squared plus z squared, right? And it's equal 30. We know that. We don't care much about it because we're going to take the gradient of x, y, z, f of x, y, z, and we have simply 2x plus 2y plus 2z in the ijk direction. So I'll write it, I'll change the plus to comma and I'll write it as a vector component like so. Okay, and now we want to find it at this particular point 1, -2, and 5. So the gradient vector at 1, -2, and 5 becomes, let's see, the vector 2 on -4 and +10. So what is the tangent plane? Well, turn out these will be the ABC. These will be the directional number, right? That's what we say. The gradient vector is direction. So the tangent plane is given by at 1, -2, and 5 is given by, well, we have 2 times x minus 1 minus 4 times y plus 2 and plus 10 times z minus 5, and all of it equals to 0. One thing I don't know if you realize, we came up with tangent plane before, but with the gradient, it's now much easier to come up with a tangent plane. All you have to do is find the gradient at the point, and that will give you the direction numbers. And you have the point, you have the direction number, you're done. Okay, so what is the normal line? Okay, normal line, the theory behind line is this. We're going to say that any line can given as a vector r of t equals some initial vector or position vector r sub 0 plus t times a vector v, right? That is parallel in that particular direction. So how are we going to work this out? In this case, we have the following. R sub 0 equals to what? It's equal to the vector 1, -2, and 5, right? That's the position. And v will be the direction vector of the will be the gradient. So we're going to write, we're going to first write the vector of the normal line. It will be 1 plus 2t, and then we'll have negative 2 minus 4t, and then we'll have 5 plus 10t. Okay, so this is the answer, but let's say we want to give it in a parametric form, parametric equation. Okay, so the parametric equation, the PE of the normal line, okay, the normal line has the direction of the gradient because the gradient is perpendicular to the plane. So the normal line, the parametric equation, if you transfer it from here, well, you have x equals 1 plus 2t, so you can write as x equals 1 plus 2t, y equals negative 2 minus 4t, and z equals 5 plus 10t. Actually, no, the symmetric equation, those are the parametric equation. What I meant to find as the symmetric equation. Remember a symmetric equation? Of the normal line. Do you remember how to do it? It will be x minus 1 divided by 2 equals y plus 2 divided by negative 4 equals z minus 5 divided by 10. Just in case you forgot. Okay, because the test was before spring break and you probably forgot how to do symmetric equation of a line. I'm done at this point. I think I took 1 or 2 minutes more. Yeah, but we started late because you didn't stop yakking.